and welcome to Programming C course. Let's start lesson 1. In lesson 1, we will be covering the basic things about computer. What is the hardware and software and basic model of computer? What is the algorithm, flowchart, programming language, compiler, interpreter? Now, what is a computer? A computer is an electronic programmable machine that can perform various operations as we like. Now, 3 words are important: electronic, programmable, and machine. Electronic because inside the computer there is a processor. In the processor, what it is doing is it needs electricity. In the circuit, there will be high voltage and a low voltage. If it is high voltage, then it is 1. If it is low voltage, it will be 0. According to those state of the voltage, then the information will be either 1 or 0. And those informations of 1s and 0s, collection of 1s and 0s will be interpreted into actionable instructions or commands by the computer. Inside the processor, it's all circuits. Just like in any electronic machine. That's why we are using electronic, because ultimately computer is also an electronic device. Now, it is programmable. Programmable means when we write programs in any programming language, what we are doing is we are giving instructions, giving commands to the computer to do certain things that we like the computer to do, to perform certain tasks that we like the computer to do. So we give the command, the computer obeys, so it is programmable. So a computer is programmable device because it follows our commands, it follows our instruction. Now again, it's a machine. Why machine? Because machine is anything that makes our job easier, faster, smoother, simpler. That's why, because it does our job which otherwise takes lots of time, difficult or laborious or boring, everything that we don't like to do, we let the computer do, right? That's why it's a machine. So a computer is an electronic programmable machine that can perform various operations. A computer consists mainly of 2 parts. The first part is hardware and the second part is software. What are these? Let's see in the next slide. Computer hardware are those physical components of a computer. Whatever we can touch and feel. For example, we can touch a keyboard. We can hold the monitor in our hands. We can hold the mouse. We can physically touch the CPU. We can touch and hold the speaker. These are the physical components of a computer. So all those physical components which we can touch and feel are the computer hardware. And inside the CPU case, there are lots of other individual parts. For example, power supply, DVD-ROM drive, motherboard, processor, and the CPU fan, RAM, visual graphics array card, sound card, hard disk. All these physical components are fitted inside our CPU case. And these are the computer hardware. Then, what is computer software? Computer software is those parts inside the computer which we cannot touch physically. These reside inside a computer. These are the set of instructions or programs instructing the computer to do certain tasks, certain work by us. So those things that we cannot touch and those things which are collection of our instructions or programs residing inside the computer are computer software. And we use our computer hardware with the help of computer software. Without computer software, computer hardware is useless piece of or objects. With the help of computer software, we are able to and utilize the capabilities of a computing system. Now, let me show what are types of software we have. Software we can categorize broadly into 3 groups. The first is system software, which is the most important heart and soul of a computer software. In system software, there are further categories: operating system, device drivers, common utility programs, and language translators. System softwares are those softwares which we need to operate our computer system. Whatever software we need to operate the computer, it is called system software. Whatever is not needed to operate the computer system, it is not a system software. As simple as that. System software means whatever software we need to operate the computer. I'm not saying to do any kind of task. I'm not saying if I want to watch a movie, I need a software, but that software I don't need to run the computer. So this is the difference between system software and other software. System software means those softwares I need to run the computer. So among the system software, operating system is the most important. Operating system operates the various hardware components of the computer and software components of the computer. It is the responsibility of the operating system to coordinate all the hardware components like keyboard, monitor, mouse, speaker, or any other peripheral device connected to the computer by the operating system, and also to coordinate among the softwares installed in the computer by the operating system. That's why it is called operating system. Without operating system in a computer, we cannot use a computer. Operating system has to be there. There are lots of operating system, different kinds of operating system. We will cover that in the next slide. For now, let's understand that operating system is that software which operates the various components of the hardware and software of the computer. Now, the next category of system software is device driver. What are device driver? Don't get confused by the name driver. Device driver means small programs. These are small softwares, very small softwares or programs required to install in the computer in order to use any other extra peripheral device. For example, if I want to connect a printer to a computer, I need a driver, printer driver installed in the computer first before I'm able to print anything. Now, if I want to attach a scanner to a computer, then I need a scanner driver to be installed in the computer before I start using the scanner to scan any kind of document. I can attach a Xerox machine to a computer also. And if I want to use the Xerox machine as a scanner, I need a Xerox machine driver to be installed in the computer. So drivers are nothing but small software program that needs to be installed in the computer in order to use that device, in order that that device is recognized by the computer. Without device drivers, the computer doesn't recognize the peripheral devices connected to the computer. It's like when you meet someone new, then you introduce yourself. Hello, my name is this and that, and so on. Like that, whenever we buy a new device like printer, when we connect to that computer, the computer doesn't recognize the printer. The printer has to be introduced to the computer. So that introduction is done by device drivers. Device drivers has to be installed before any extra peripheral device is connected to a computer. Now next is common utility programs. Common utility programs are small programs to enhance the functionality of a computer. For example, there are lots of temporary files in the computer. It may slow down the computing speed. So we can clean the temporary files by using a disk cleaner. So to clean the temporary files, we use a disk cleaner. That disk cleaner is a utility program. It enhances the capability of the computer. Or it may be a defragmenter. Defragmenter means a small program which defragments the computer memory. When we store something in computer memory, everything is scattered. By a defragmenter, we collect all those what is stored in the memory in one part, and we keep the unused part of the memory in another part, nicely, systematically. That is the job of the defragmenter. So that is also a utility program. So like that, there are lots of small programs which enhances the functionality of the computer. Those are called common utility programs. Now lastly, we have language translators. These are compilers and interpreters which translates a high-level programming language into a machine language. This we will be covering in this chapter later on in the last part. The language translators are also softwares, a kind of software. Now let's come to application software. Application softwares are those softwares which are not required for running the computer system. But if I want to do some other tasks like typing a text document in the computer or making a numerical table and doing all kinds of calculation in the computer with the help of MS Excel, or if I want to listen to music with a media audio player, or if I want to watch a movie with a media player, then those media player, audio player, MS Word, MS Excel, all those are called application software, right? If I want to play a game, I have to install the game in my computer. That game is again application software. These are extra softwares that we install in our computer in order that we are able to do whatever we want to do. Those softwares are called application softwares. All kinds of software we install in our computer besides system software is application software. And the last type of software is malicious software, not so much well-intended software. Bad guys. These are programs or codes written to harm, to destroy, to corrupt our computer. These are the bad guys, villain of the movies. Now, we have heard about all kinds of virus, crimeware, adware, spyware, all kinds of these things. These all come under the category of malicious software. Right, so these are the third type of software. Again, system software is those software which we need to run our computer system. It controls and coordinates the computer hardware, and it provides an environment for running the application software installed in our computer. System softwares are of four types. Operating system, examples are Windows operating system, Macintosh operating system, then Linux operating system. I've told you about device drivers also. It may be printer driver, scanner driver, photocopier driver, etc. And utilities are small programs which enhance the performance of our computer, like registry cleaners, disk cleaners, etc. Now, let's see what is an operating system in detail. An operating system is a software which operates the hardware and the software installed in the computer. So it manages all the hardware and software components of a computer system. That's why it is called an operating system. Without an operating system, we cannot operate the hardware components of the computer. It acts as an interface between the hardware and the user. Now, in the left side, there is a diagram. In the diagram, first, we have the computer hardware. On top of that, we install the operating system. Then, on top of the operating system, we install the application software. Then, we use the application softwares. So, that means operating system is the interface between the hardware and the user. All right. Application software sits on top of operating system, and we communicate with the hardware through the operating system. So operating system helps in running our application softwares also. And there are popular three operating systems. You can see their logo on top of the slide: Windows, Mac, and the Linux. Now, what is an application software? A software which is developed or written to perform certain specific tasks according to what I need. Application software. Now, we have lots of application software depending upon the tasks we want to do. Like if we want to type document in the computer, we use a document software. If we want to edit a photo, then we use Photoshop. If we want to play a movie, then we use a media player. If we want to surf the internet, we use a web browser. These are all kinds of applications. Now let's go to third kind of software, that is malicious software, which is in short known as malware, taking the mal from malicious and ware from software. Malicious software refers to any kind of malicious programs of software that causes harm or corrupt or computer system or a network. Their intention is not good. There are lots of malware types. Some of them are viruses, trojans, rootkits, worms, spyware, crimeware, and adware. Let's see this one by one in the next slide. A virus is a malware written to alter the way our computer operates by attaching itself to a legitimate program or document in order to execute its code. Most often, virus attaches to executable files in our computer, and when we run or execute those legitimate programs, since the virus has attached to that executable program, it will execute its code as well. By doing that, we corrupt our files and programs and software inside our computer. That's how virus operates. The second type of malware is Trojan. A Trojan is a malware, malicious software, pretending to be a legitimate software. But actually it is not a legitimate software. It sneaks into your computer by pretending that it's a good software. Next kind is rootkit. Rootkit is a malware designed to give attackers root access or admin access to your computer system. When you buy a computer, when you buy a laptop, there is a admin account and restricted account. If you have an admin account, then you can install, uninstall softwares, make changes, delete files, can do all kinds of things. Restricted accounts cannot do all kinds of things. That's the difference between admin account and restricted account. So what rootkit does is it gives attackers root access or admin access. And if you want to steal something from your computer, they can do it through that means. And if they want to make changes, they can do through it. Okay, so the next kind is worms. Worms is a kind of malware that spreads across a network. The network may be a local area network or a wide area network or World Wide Web, that is we usually call internet. They don't require any host system. Without any user action, they can spread through the network. Next type of software is spyware. Spyware is a kind of malware designed to spy or steal our passwords, our credit card details, our personal data, and other online behavior patterns. Similarly, crimeware is also a kind of malware that is designed to perpetrate crimes, such as they can steal our personal identities, they can steal money from bank account and other proprietary information if we are a company. So crimeware are more dangerous than spyware. And the next one is adware. Adware is a malware that floods victims with unwanted ads and opens up vulnerable security spots for other malware to wiggle its way in. When we visit a website, then all kinds of ads are pop up out of nowhere, and those pop-ups, they may contain malwares. If we click those ads, then some malware might infect our computer. So when we visit any website, we should not click on the ads. We should be very careful clicking on the ads, because those ads might contain some malware and they will find a way to come into our computer system through the ads. Now, how does malware spread? When we download free software or free files from the internet, the viruses, the worms, the spyware, they might come through that means. And when we click on suspicious pop-up ads, we give a chance to the malware to come into our computer also. And when we click on email attachments or text attachments sent by unknown persons or unknown companies, then we might get infected with the virus also. And when we share files among our friends, P2P means peer-to-peer file sharing, those files might contain malwares also. And when we visit malicious websites, unknown websites, then also our computer might be infected with virus. Okay, so even your phone, when you download and install unreputed apps, then it might contain some virus or malwares. Then when you share audio files or video files, then or funny images, it might contain some malware also. So you should be very careful. So what precautions can we take? So in order that the virus cannot infect our computer or phones, we should be very careful when we surf the internet and when we download files, when we click on links or when we click on attachments. We should be very careful because those attachments and links might contain some malware. So what should we do is we should never download text or email attachments that we are not expecting from unknown persons. We should not download files from websites that we don't trust. If we practice this, then our computer or phone might not be infected with malwares. Now let's come to block diagram of a computer. A computer has four main components: input device, memory, central processing unit, and output device. I have kept here memory and central processing unit separately because of one reason. In fact, there are only three parts: input device, CPU, and output device. Now, what is an input device? Input device, our keyboard and mouse are input device. And inside the central processing unit, there are actually three parts. The first is memory, the second is ALU, that is arithmetic and logic unit, and the third is control unit. These reside inside the CPU case, and the output device is our monitor or our printer. Now, inside a computer, when we give some information, how it is being transferred through the computer system, let me explain you. When we type on a keyboard, that is our input device. When we click through our mouse, then that data or information is transferred to the memory, that is RAM, random access memory. Then from the memory, it is transferred to ALU, that is arithmetic and logic unit. If there is any computation to be done, it is done at ALU. And if there is any decision to be made, it is done at ALU. Then after the computation and decision has been made, the data is transferred to memory. Then from memory, it is transferred to our output device to show on our monitor. That is the transfer of data. It is shown in brown color. While the computer is doing all this, some part is controlling the transfer of the signals, and that is done by the control unit, CU. Control unit is responsible for sending the signals from input device to memory, from memory to ALU, from ALU to memory, and then from memory to output device. Control unit is controlling the sending and receiving of signals among the various parts. The memory and the ALU and CU is inside the CPU case. I'm keeping memory separately here to show that all kinds of data transfer goes through the memory. Now, what is an algorithm? An algorithm is a step-by-step method or procedure of solving a problem or doing a task. We can view a computer program as an elaborate algorithm, very long algorithm. Where do we use algorithm? In mathematics and computer science, we use algorithm usually to solve a recurrent problem. I'll show you a very simple example of an algorithm of adding two numbers. Algorithm means step-by-step procedure of doing a task. So step number one, we start, and step number two, the values of two numbers and stored at A and B. Then step number three, we add the values stored in A and B and assign it to C. Then step number four, we print or display the value stored in C, and five, we stop. The step-by-step procedure of doing something is called algorithm. Now, what is a flowchart? A flowchart is a visual representation of the sequence of steps that we have written in our algorithm and decisions needed to perform a process or a task. Flowcharts are widely used in analyzing, designing, documenting, or managing a process in industries or computer program in various fields. For example, on the right side, there is a flowchart of the same algorithm we saw in the last slide. Let's go to what is a computer program. A computer program is a collection of instructions that can be executed by a computer to perform a specific task. So this is the third step. First, we write the algorithm. Second, we convert it into some kind of picture so that we can see the transitions, the process, how it is being proceeded. Then third step, we write computer program in a programming language. You can see a simple program. I won't tell you much right now, but what it is doing is the same thing. It is taking the value of A, it is taking the value of B, then adding those values and storing at C, and lastly, it is printing the value of C. This is a C program. We'll do this later on. Now let's come to programming languages. A programming language is a set of instructions through which humans interact with computers. Without programming languages, we cannot communicate with the computer hardware, because whatever language we are speaking, the computer hardware doesn't understand. So we need a programming language to write programming codes, instructions in order to communicate with the computer hardware. There are different kinds of programming languages like machine language, assembly language, high-level language. Let's see these one by one. First, let's see what is low-level languages. Programming languages such as machine language or assembly language, which are closer to the hardware or machine than the human language, are known as low-level language. Our hardware understands only binary numbers, that is 0 and 1. And assembly language is a little bit upgraded from the machine language. These two languages, machine language and assembly language, are very close to the hardware. They manipulate the hardware. So that's why they are called low-level languages. And we will cover this in the coming slides in detail. Let's go to the next slide. What is machine language? Machine language is the lowest level programming language. It is the only language understood by a computer. It consists of only ones and zeros. Now, why don't humans use machine language? While easily understood by computer hardware, machine language is almost impossible for us humans to read and write because it is entirely of zeros and one. So programmers therefore use either an assembly language, a high-level programming language to write a program. Next, let's go to assembly language. Assembly language is a low-level programming language that consists of instructions written in mnemonic codes, that is shortened names, instead of the numbers in machine language. Assembly language is one step further from machine language. That's why assembly language is a little bit better than machine language in understanding. Assembly language is the most basic programming language available for any processor. Each type of processor or CPU has its own machine language and assembly language. So an assembly language program written for one type of CPU won't work or run on another. So machine language and assembly language are dependent on machine. Assembly language generally lack high-level conveniences such as variables and functions as available in high-level language. Now, what is a high-level language? A high-level language is a programming language that is closer to our human language than to machine language. A high-level language focuses more on programming logic, how we are supposed to do a certain specific task to accomplish that task, rather than worrying about what kind of hardware we are using. If we are writing a program in assembly language or machine language, then we have to keep in mind what kind of hardware we're using, what kind of processor we're using, because assembly language and machine language are processor dependent, hardware dependent. But the high-level languages are independent of hardware or processors. That's why we don't need to worry about what kind of hardware we're using. We have to focus on how we are supposed to do any particular task, how best we proceed in order to accomplish that task. So we focus on the programming logic. That's why it is very convenient for a programmer to write program in high-level language. And why they are called high-level language? Because the language being used in high-level language are very close to our human language. For example, in C language, we use printf function to print something on the monitor. So printf means print formatted text. So it is very close to our human language, but that is not true for machine and the assembly language. So all kinds of instructions, all kinds of keywords used in high-level language are very close to our human language. That's why they are called high-level language. Advantages of high-level language. High-level languages enable development of a program in a much more user-friendly programming context, are generally dependent of the computer's hardware architecture. It is easier to read, write, debug, and maintain. It is also portable. Portable means it can be transferred from one computer made by one company to another computer made by another company, because it doesn't depend on the computer hardware. It is independent of computer hardware. So the program of the software can be transferred from one computer to another. Now let's see in brief the whole of the programming languages. Now in human language, if we want to assign C the sum of A times B plus 10, then in some kind of high-level language, what we're going to write is C is assigned the sum of A times B plus C. High-level language is very close to our human language. Now, if you write the same information in assembly language or mnemonic codes for doing the same instructions, multiply is written as mul, addition is written as add, move is written as mov. So like this, we write in codes in assembly language. Now further down in the assembly language, there is machine language. In machine language, everything is written in numbers. You can see there is some letters A, F, A. These are not letters, these are actually numbers. How? Because these are hexadecimal numbers. In hexadecimal number, there are 16 digits, 0 to 9 and from A to F. A is number 10, B is 11, and so on, and F is number 15. So what you're seeing here is all numbers, and these hexadecimal numbers have very close relation with binary numbers, and these hexadecimal numbers are converted ultimately to binary numbers so that the hardware can understand. Binary codes or binary numbers are very long. They are too lengthy. So in order to write the binary numbers in short, we use hexadecimal number in computer. Now let's come to source code and object code. A program written in any language other than machine code, typically a high-level language, is called a source code. Now what is an object program or object code? A program into which another program is translated by an assembler or compiler is called an object code. That means a program written in any high-level language, if it is converted to other programming language, that is assembly language or machine language, then that converted program is called the object program. Now, what is running a program? There are two ways to run a program written in a high-level language. The first one, we take the help of compiler to compile the program and run the program. The second one, we can do with the help of an interpreter. I will explain this compiler and interpreter in the coming slides. Now, let's see compilers. Why do we need it? Compiler is a system software that translates the programs or codes written in high-level language to machine-level language, that is object code. What is written in high-level language is source code, and what is converted to machine language is object code. So we use a compiler to translate the program written in high-level language to a machine-level language so that our computer hardware understands our instructions or command. Now, examples of compiler are, we are talking about C compiler, Turbo C, GNU GCC compiler, Tiny C compiler, Portable C compiler, Digital March C compiler, etc. The compiler derives its name from the way it works. Compiler looks at the entire piece of source code in our high-level language, collects it, reorganizes the instructions, and later on translates it. That's why it is called a compiler. Next is interpreter. Interpreter is also a similar software. It is used to translate a program written in a high-level language to a machine language. How is it different then from a compiler? An interpreter analyzes and executes its line of source code in succession without looking at the entire program like a compiler. Usually, interpreter is a smaller and simpler software than a compiler. Now, let's see the differences between compiler and interpreter. Compiler converts the whole program to machine language. This converted program may be stored somewhere in memory and then may be executed without requiring the presence of the compiler. When a compiler converts a program into machine language, it converts the whole program at one time and store it somewhere in memory. When you want to run the program, in fact, you don't need a compiler. The job of the compiler is done. It has already translated the program and it is residing somewhere in memory. Now, an interpreter converts the high-level language program one line at a time to machine language, then executes that converted line. Then the next line is converted and executed and so on. So the presence of an interpreter is a must while running a program, because since it converted the source program line by line, after finishing the translation, when it wants to execute the program, it still needs the interpreter. Compilers require some time before an executable program emerges. It takes time to translate by a compiler. But the advantage of interpreter is that it can execute a program immediately. As far as execution is concerned, interpreter is fast. However, program produced by a compiler runs much faster than the same program produced by an interpreter. Here is the advantage of, again, compiler. The programs translated by a compiler runs much faster than the same program produced by an interpreter. Why? Because compiler looks at the whole program, organizes it, translates it, then after that, it runs the program. Since it has already organized all the source code and translates into machine code, takes less time in running the program. But an interpreter, since it translates line by line, it takes more time in running the program later on. That's the difference between compiler and the interpreter. Now we can compare its feature. A compiler scans the entire program and translates it as a whole into machine code, but an interpreter translates program one step at a time. A compiler takes large amount of time to analyze the source code, but the overall execution time is comparatively faster. But an interpreter takes less amount of time to analyze the source code, but the overall execution time is slower. Compiler generates intermediate object codes, which require further linking and hence requires more memory. What it means is, when a compiler translates the high-level language program, sometimes it may not directly translate to machine language program. It may translate to some other intermediate level programming language, for example, assembly language. From a high-level language, it may be translated to an assembly language, and then from assembly language, it may be translated to machine language. So it takes time. An interpreter does not generate intermediate object codes, hence is memory efficient. Interpreter directly translates a high-level language into the machine language. So it doesn't require the use of the memory, and hence the memory is efficient. Compiler generates error message only after scanning the whole program, and hence debugging is comparatively hard. Debugging means correcting the errors. In computer, bug means any kind of error in a program, and the correction of those errors, the process of correcting those errors is called debugging. Since compiler gives us the error message only after scanning the whole program, debugging is difficult or it takes time, because at the end of the process, it shows us all the errors together. But interpreters translates the program line by line, and whenever some kind of error is met in the way, then they stop translating and show us the errors. Hence, correcting the errors or debugging is easier. Now let's come to assembler. An assembler is a software that translates a program written in assembly language, that is numeric codes, into machine language, that is zeros and ones. That is job an assembler, just like a compiler. Compiler is a more general term, but assembler is a specific term. Assembler translates from assembly language to machine language. A compiler translates from any of the high-level language to an assembly language or a machine language via the assembly language also. That's the difference. That's all for now. Thank you, everyone.